Shalom. Shalom, beautiful people. First of all, I would like to thank Dave Rich, my new Patreon. Thanks very much, man. Next, I would like to show, greetings everybody in chat, by the way. Oh, this is going to be a good one. And it's going to be one where at least half of you in the chat will be able to just sit back, put your hands behind your head and just relax and rewatch something you've already seen. But to some of you, it will be new. This goes to the Globlings in the chat who have this idea that I'm afraid of debating Rekt's rhetoric. You'll have 100% proof that the fact is the other way around. It is Rekt's rhetoric that's afraid of debating me. So you're going to see a kind of very rough debate that he had pulled, that it was not on his channel, but he asked the person to pull it, and the person pulled it. However, before it was pulled, after I was in the Hangout, I rewound, recorded from a screen grab, recorded the audio, and put it together. That's what you're going to watch. Immediately after the Hangout ended, it was pulled. It disappeared. Rekt's Rhetoric has done that with 2 Hangouts on his channel with just me and his gaggle of friends. Okay? Who's afraid? Who's afraid here? So, first, we're just going to see, to put that Hangout in context, we're going to watch this. Enjoy, Globe Believers. I'm playing it without audio. It's a cool video, by the way, by DJ Sadhu. Here, I'll scroll up, you can see it. The helical model, our solar system, is a vortex. This is the old-fashioned model. Okay? So I'm going to go back, watch again, Globelings. The old heliocentric model of our solar system. You know, the one that they showed in E.T., planets rotating around the sun. The one that you were taught at school. This is it. Okay, so sun and planets revolving around the sun and moons revolving. It's not only boring, but also incorrect. Our solar system moves through space at 70,000 kilometers per hour. Oh, now picture this instead. Oh, good gosh, look at that. First, there's a problem. The sun doesn't have a trail like that. Shouldn't it have some kind of comet trail? 70 kilometers per hour? Shouldn't it have some kind of, well, trail? But no. But apparently, according to NASA, yes, it does. It's just, you know, particles that we don't really see. Okay? True story. The sun is like a comet. Oh, dragging the planets in its wake, except it doesn't have a comet trail. Can you say vortex? Very beautiful. Since then, he's created other renderings of the same that are much, much more beautiful. It's all fantasy, but still much more beautiful. So here we go. There you go. Solar system traveling through space. Now, let's watch this. And this is where half of you can just sit back and go, oh yeah, we know this. Okay? I'll give a caveat first of all. This took about 2 hours. What you're about to see condensed into 34 minutes took in real time around 2 hours of me being continuously muted by Red and his friends. Okay? Okay. Let's go.
Can I just ask if anyone wants to leave? This Antonio Subarats is trying to get in.
Oh, shit.
Right, I'll tell you what. I'll back out so Antonio can get in. Let me back out. Antonio.
All right, Antonio, get your ass in here.
Hats off to you, sir. Way to take one for the team.
The guy who just backed out was a flat earther. There was a flat earther who just backed out. The other guy who has the icon of King of the Hill, that guy, he was a skeptic, a globe skeptic. So there was one flat earther, a globe skeptic, and me. Okay.
I had to take my head off to that motherfucker. That motherfucker.
Hello?
Yeah, hello.
Yeah. Where's Poncho Pete?
He dropped to let you in.
Oh, nobody wanted to drop. Am I causing any feedback?
No.
Okay, so, question for Gem Panda. Hello there. How are you?
I'm alright, thank you.
Jolly good. Okay, so I have a question for either you or Gem Panda. Which would you like to answer this question? No, it's not so much a question, but it's more a request for everybody in the chat. Can either of you explain the difference between centripetal and centrifugal force, please?
Point of reference.
Well, I'm going to let Red do that, but before I do, Antonio,
Yes.
don't have to. Everything doesn't have to be a gotcha. Knowing what I know of Antonio, it's unlikely he's going to come in here and make some sort of heavy scientific debate with Red.
Okay, so the question
I think he's got a different angle that he wants to approach it from, and I think we should at least allow him a few minutes to do that. And hopefully you'll stick around, Red, and we'll get back to the science when Antonio
I hope so, because that's what I'm actually here for, because I'm not here talking about
I understand that, mate, but
Wonderful. Now, you both heard my question about centrifugal and centripetal force, did you not?
Right.
Correct.
Yes. Which of you would care to describe these two forces to the people listening? So, either Red or Gem Panda, would either of you please, for the benefit of the listeners and subsequent listeners, describe centripetal and centrifugal force?
Okay, so anyway, they're two sides of the same coin. Centrifugal force is the tendency of an object following a curved path to fly away from the center of curvature, when a centripetal force is a force that keeps an object moving along a uniform path around that point. A uniform path around that point. Both of them use the same equations. That would be F little c equals mv to the second over r. And if you look at the other one, its equation is also Fc equals mv to the second over r. Why the fuck do I know these things by heart?
Okay.
Yeah, I know that too, right?
It's frustrating that I have to fill my head with all this stuff.
But Red just beat me to it.
Okay. So,
anyway, so do you have a science question or something?
Yes. Less with the impatience. Patience is a great thing. Okay.
I wish I had that.
Okay. So, centripetal versus centrifugal, both the same equation. Okay.
Yes, both same equations.
The same event happening.
It's revolving around, rotation around a body.
Yes. But if you're describing it with equal equations, it's the same event, is it not?
Yeah, you're going along a curved path, and there's a force to be introduced on that curved path.
There are two forces.
No, there's one force, and that's a force you're going to be falling out.
No.
When you fling it out, so it's like here's the it all determines a series of events. So, for example,
no, you don't need to give examples. We've all seen, we've all done things.
Okay, then if we all heard examples, I'll ask you this: What
No,
would
no.
mud?
Because
Hang
you
on,
had-
hang on. Mud flying off a tire would be an example of what?
Say again.
Mud flying off of a tire at speed would be an
No,
example
no.
of
Don't
what?
bring irrelevant things, okay? You've described.
Okay, if you don't want to bring actually relevant things into us, I
Yeah.
understand.
No, you've just quoted two equations which are the exact same equation. Well, one equation which is actually a mirror image of itself. Yeah. For describing two demi forces, because they're not actual forces, are they?
Yeah, they're forces.
Yeah, they're forces.
Okay, so two different forces, and
Same force.
Oh, okay. So spinning away from something is exactly the same as being pulled towards it.
It's an idea about rotation.
No. Something being.
It's all about what happens after the fact, after the force is applied. That's when you have the different, because in centripetal force, you have an object staying in orbit. With centrifugal force, you have objects being flung away.
So
Both of those require a spin, and both of those require a spin of the same equation.
And away is the opposite as towards, or are they now both the same thing?
The only
No.
difference is the direction.
Yeah,
Yeah.
direction, correct.
Yeah. So
So
one
yeah,
is
so yeah.
away from the body it's orbiting, and the other is towards the body it's orbiting. Is it not?
Yeah, both of them refer
Yeah.
to rotation, correct.
Centrifugal away, centripetal towards.
Yes. So the two equations describing the two different forces balance
Same
out.
force.
No. Yeah, it balances out to zero, does it not?
Bounce it up to no.
If it
No.
can.
Okay. So,
What does that
Now-
even mean?
you wouldn't understand because you weren't taught it. You weren't taught it, so you wouldn't understand. You can't expect that you're going
Well,
to.
don't make that assumption. Don't make
Oh.
that assumpation.
Well, you're just asking what it means. If you've been taught it, you wouldn't be asking.
No, I'm asking what you mean by it.
No, it's got a straightforward meaning. You can look it up afterwards. But now, here's the thing. We're talking about centrifugal versus centripetal force, which is basically describing the orbit of the planets around the sun or whatever is orbiting whatever else. Correct?
Being in orbit or getting flung out of orbit. Both
So-
of which still require an orbit.
So it's describing orbit, correct?
Yep. Either staying in orbit or getting flung out of orbit.
No. You can't have two different things being the same thing.
Those two different
You
things
just
are two different results. That's why they have two different names.
You just said that centripetal and centrifugal are the same. Now you're saying that the two things are not the same.
The
Right.
events that happen,
Oh, they're not the same.
as a result of those equations are what
No.
give it its name.
Events don't
No,
happen.
yes. If you had been
Hey,
been learning this, you would know this by now.
Listen, man. Things don't happen as a result of an equation.
Oh, really?
Things happen as a result of an equation.
Things get described by equations, and then we can figure out what happened.
Yes.
And so you agree with me. Thank
kind
you.
of irrelevant. It's like the equation is after the fact, really. It's just a way of describing the event. The event happens irrelevant of the equation. It happened before the equation was figured out. Okay? So, now my scientific question for you and Jampanda is this. The body that's being orbited, okay? So, let's say the sun. And let's say the thing doing the orbiting, let's call that the Earth. Okay? Is the sun static in space?
Relative to what? The center of the Milky Way galaxy?
Is it static?
The sun is static in our solar system.
No, it isn't.
Yeah, if you're keeping it. Okay, so it's not confined to our solar system.
No. I asked, is the sun static?
Relative to what?
to not static.
What? Relative to what?
Relative to... Do you understand what the word static means, don't you? It
And
means
do you know
not
what the word
moving.
relative means?
Yes, I do. Okay?
Okay, then why don't you answer the question? Relative.
Hey, Reds. Is your friend on his way to your house? On his way to my house, through which route? Is he on his way to your house? Depends which route you're talking about. No, the question is he on his way to your house? See, that kind of thing. I mean, that's a lame example, but that kind of thing. But let's continue. It was great.
Relative to what?
No. Static means not moving.
Relative to what?
What the fuck relative to what? Is the sun
I'll just answer the question.
moving?
Relative to the Earth.
Relative,
No.
relative to what?
No. Forget it. This is a little rabbit hole. Okay,
Okay,
relativity is a bunch of bullshit.
Alright.
Let's
Well,
talk
it's
plain
not-
English. Is static something that's not moving? Is that what static means?
Static can be something that's not moving relative to something. Motion
You're
is relative.
No.
Static is.
There's always a point of view from which it is not static. Okay.
Let
As long
me
as there's one
answer.
single point of view,
Let me answer.
as long
Let me
as there's
answer.
one single
Let
point
me
of
answer
view,
the question in both ways.
Hey,
And I
as
answer to
long
get
as
this
it-
figured out.
as long as there is a point of view that can see it as not static, that's all that matters. Not whether
So relative to the Earth, then, right?
you're trying to bring in relativity to get out of a simple question. Is the sun moving or is it not moving?
It's not moving within its own solar system. It's
That wasn't
moving
the
relative.
question. Do you
Oh,
don't,
then
you don't
what the
understand
fuck
the
do you
question.
mean? How am I
Is
supposed to
something
figure this shit
moving
out?
or not moving? You're
Are we
supposed to think of the Jeremy.
Are
do you know
you
whether it's
talking
moving
about
or not
relative to the center of the galaxy?
I do understand the distinction that he's making, and what he's
moving?
saying.
I understand the distinction that he's making.
Obviously
Right, well,
not.
why-
Otherwise,
why-
it wouldn't
why-
clarify.
Again,
In
trying
extra
to-
elements.
Why are you? Why
Simple
bother
question.
saying it? Let me
It's
answer.
a
You
simple
answer.
question.
You answer
Is the
that.
sun moving or not moving?
Why?
Relative to
why-
what?
Again, are you trying to create this sort of gotcha question? Let
It's
him
not
give
a
full-
gotcha question.
Yes, it is. Let him give a
No,
full
it isn't. You keep
Yes, it
thinking
is.
it's a gotcha question.
Yes, it
It's a
is.
simple question.
Yes, it is
And
because
you keep
you need to
thinking
know.
it's a gotcha question, so you keep looking for a way out. It's a
No.
simple question.
Okay.
Because
Stop making
all right,
assertions.
let me.
Hang on. Stop making assertions and answer the question. If you know the difference, if you were educated on it, then you should be able to tell me. Do you mean static as in static within the solar system and we're only paying attention to the solar system itself? Or do you mean relative to the center of the Milky Way, which is external to our solar system? Which one are you pointing to?
You're muted.
Unmute.
You're muted, Antonio.
Does anybody here that has a brain actually understand the difference and how it could be?
I think I was muted maybe 50, 60 times in that hangout by Rhetoric and his pal in the blue shirt. Mainly. Okay, other people too, but mainly those two. So, who's afraid of debating?
Red, you
Oh.
muted me.
Correct.
Yeah, you're asking relative to what? Okay, and you would like me to answer relative to the solar system or the galaxy? No, relative to space. That's where movement happens. So is the sun moving relative to space?
And what point in space?
What's wrong with you? How can you
Yeah,
not
I
answer
should
this
ask you
question?
that same question.
How can you not answer this question?
How can you not answer that question? That is my question. How are you
Did you
finding
answer
this
it?
so difficult to answer?
Can
I'm
you
trying-
answer it?
Okay, so you want me to answer something in which I don't know the actual question.
You don't know whether or not the sun is moving through space.
I know it's not moving relative to its solar system. I do know it is moving relative to the galaxy.
So
Which
is it
one is it?
relative to
Which
space?
one is it? Is
You
it
should
A or
be
B?
How are
You
you
should
guys
be able
hung
to
up on the
figure out
question for
whether
so
it's
A
long?
or
moving
B?
relative to space.
Antonio, is it A or B? Is it A or B?
No.
Is it A or B?
You should be able to figure out.
Antonio, is it A or B?
Moving relative
Is it
to
A or B?
space.
I'm not a mind reader. Antonio, is it A or B?
I'm gonna mute you. Okay?
All right, that's
Is it
the
A or
new
B?
limit, guys. Come on, let's act like gentlemen here. Let's
Is it A or
get this figured out. Somebody's got to compromise, or we're just gonna.
Okay,
have to
okay, how about
agree
this?
to
Can
disagree.
someone else answer the question for this dipshit? Because obviously he's
Yes,
incapable of
because
answering
you
it
can't
himself.
answer the question.
I'm going to assume he means relative to the solar system. In which case, no, the sun is not moving relative to the solar
no.
system.
You don't want to answer the question because you think it's a gotcha question.
I just answered it, and I'm going to assume your answer because you refuse to answer it yourself. So I'm going to assume what it is. I'm going to assume your question, so I can give you an assumptory answer based on your assumed question because you were unwilling to clarify.
Okay, I'm going to have a look to see what people are saying in chat, just to see whether they understand what movement through space means.
I'm sure there'll be loads of flat earthers who think you're really cool, Antonio.
No. Apparently,
Ask the question properly.
I've asked the question properly. You're saying, can you ask the question in a way that we can answer it?
Just give him both answers, Red.
Okay, I'll give them both answers.
No. The question has a simple answer. Is the sun moving?
The answer is going to be different compared to which
The answer
one you're
is
talking
yes. The answer is yes.
to. Okay, so all he had to say was relative to the center of the galaxy.
Hey,
Right, that's all he
Hey, Red,
All he needed to say
stop
was
muting
relative
me.
to the center of the galaxy. Okay, so relative to the center of the galaxy, what's your question?
Stealth.
You're muted.
Self, dude. Okay,
Please stop muting each other, guys.
right.
So,
Not
Red,
that I understand the context.
with the muting, okay?
So yeah,
I've answered my own question. I have answered my own question, which you wanted me to do. Is the sun moving through space? According to orbital mechanics, yes, it is. Apparently, neither you nor Jeremy had the fucking intelligence to understand that simple question that a 5-year-old could have answered.
We
and a
asked
5-year-old
for
would have
clarification.
known the difference between relative motion. Relative to you, the steering
Red,
wheel is still.
Red.
Relative to the hitchhiker, the steering wheel is moving.
Hey, Red.
Even a fucking 5-year-old could have figured that
Hey,
shit
Red.
out. Holy shit, you're a dumbass.
Hey, Red, did you understand the bit where kind of the whole panel agreed that we wouldn't mute each other?
Did you miss the bit where we wouldn't just make
No.
baseless assertions?
I just asked you a question. Did you
Oh,
hear
come
that?
on.
Or did you have a problem with normal kind of
Antonio,
interaction?
Antonio, you're making points out of nothing, aren't you? Now you're
No,
making
I'm
a point
not.
out of the muting. Before that, you make
This guy, James Panda, is absolutely insufferable. What he does is he just continues talking in circles, the same point over and over and over, and it turns out just about, I don't know, 90% of the time, that his point is dead, that it's not a real point, it's just a way of just, I don't know, flexing his vocal cords. Just listen to what he says.
you're trying to make a point out of the fact that you weren't prepared to clarify your question.
Why would I make a point out of that fact? That's just retarded.
All you had to
No.
do was clarify the question.
Clarify it. You said
And
relative
you
to
tried
what?
to make the point from the fact that you were being awkward and uncharitable
No.
and
1
wouldn't
second.
clarify your question. And
He doesn't seem to understand motion's relative.
that we were trying to avoid answering it. Red was
On
prepared
behalf
to
of the
answer
audience.
both versions of it.
You think there are 2 versions of it? Okay.
Yes!
Yes.
Actually, there is.
Yes.
Actually, there's
No,
billions
there isn't.
of versions.
Actually, there
Listen,
isn't.
Antonio, there's billions of versions.
Red.
Billions of
Be
versions.
open to the idea.
No, billions of versions.
No.
Billions.
Yes. Yes.
Trillions
Now,
of
The
versions.
audience has to work in the morning, guys. The audience has to work in the morning.
You
Let's
asked me to verify. You asked me to
I keep talking with these intellectually dishonest flat earthers, trying to get clarification to a question, and they simply do not want to do
Red,
it.
I'm trying to talk to you, but we're having a hard time doing that.
Okay, how about this?
People in
Stephen,
chat-
please talk
Hey,
to him and
the people in chat.
try to get to
Like,
answer.
like yesterday, where he tried to claim that because I didn't know where the Gobi Desert was.
At this point, Gem Panda completely fabricated something that had not happened on a previous day's hangout, where I simply pointed out that he did not know where the Gobi Desert was, and he was claiming that all the deserts of the world were on the tropics. I pointed out the Gobi Desert isn't on the tropics, so I asked him where the Gobi Desert was, and because it disproved his point, he like Astronomy Live has been doing with his unflipping of an image. He tried to make it into a thing where the thing that had happened there was there'd been a transgression by yours truly in highlighting the point that he was wrong. He flipped it and tried to make something that wasn't. He tried to come out as the victim out of me having lied. But no, I just pointed out something that's true, that's definitely true, and this is what the Globelings do. There are Globelings in the chat right now doing the same thing.
I would like to ask, for a sec, I want to ask the moderator of this hangout, if we even have a fucking moderator of this hangout, a question, because I usually don't do this without asking first. Hang on, I'm not talking to you. Question.
There is no moderator.
Okay, so now we're fucked, because I want to ask if I could at least take this part of the hangout and upload to my channel, because I want to show
Oh, yeah.
Simply will answer your question.
However, after having asked that live in that hangout, he asked the person to pull the hangout altogether and did not mirror this portion of the hangout on his channel. Don't believe me? Go and look on his channel, see if you find this hangout on his channel. He must have changed his mind. Huh. Wonder why.
Because I want to show an example of what not clarifying your question actually is.
Now, what you were doing was you were trying to sequester the question and put it in a tiny little box. Now, we don't live in a world. Dude, can you wait until I'm finished talking? Okay? So, you asked relative to what? Then you gave two options of what I could say it was relative to.
You can say whatever the fuck you want. Those were two suggestions, not options.
I did. I said relative to space.
There's billions of shit in space. Space
Doesn't
isn't one
matter.
point.
Yes. The sun. We're talking specifically about the sun and whether or not it is moving through space.
There are objects in space that it moves relative to, but if you're talking about within the solar system, it doesn't move in space.
Your brain has not processed what's being asked.
Space doesn't have grids. Space doesn't have a grid pattern that you can figure out.
What are you talking about grids for? What are you talking about grids that don't exist for? Who brought up grids?
Exactly. That's why you need to clarify your question and tell me exactly what's relative to.
Space.
If it's not relative to an invisible grid, then you need to tell me what it's relative to. Figure your shit out, figure out your question, and ask it properly.
Now, who's muting people?
Hey, Antonio, I got a question for you. How fast is my phone
I'm
right
asking
now?
you. Okay, I said, this question is regarding centrifugal and centripetal force. Now, for this, we're going to be talking about the sun and the earth.
Solar system.
Okay.
Got it. Let's do this.
Got it? Okay, now, is the sun moving through space? The answer is yes.
The answer is no. The answer is no.
Apologies, that was an editing error.
Thank you. I can pull this down too, can't I, guys?
You can. Absolutely.
Right, so Rhetoric, the sun is not moving through space. Jeremy, do you want to chip in?
Well, I wanted you to finish the rest of that question because it seemed like you were building up to something.
I was.
Where were you going from there?
This is where I was going. So, centrifugal and centripetal, okay, around a point. Yeah? I'm describing a point. If anybody wants to look, you don't have to. Now, if you move the point that it's orbiting around, yes, you've changed the force, haven't you? No, you haven't.
No.
Red, you don't count. You can't answer anymore because you think the sun is not traveling through space. So, Jeremy.
Unfortunately for you, I can because you're actually confusing two different models and
No,
those two
I'm
different
not.
questions. I knew you would do this. Hey, guys, I am going to pull
I
this
am
down
not.
now. I am.
It was very simple. Now he's going to proclaim that he's going to pull that hangout and put it on his channel. However, he failed to put it on his channel. Oh dear.
I am going to fucking expose you as the dipshit you are. Thank you.
I am
so
not.
much.
Yeah, wonderful. Wonderful.
But it should be, I just want to point out that it should be really, really clear to everybody that's watching on either side that he was trying to formulate a gotcha question but wasn't ready to clarify because he realized it messed up his gotcha question. And
the problem with globalings is that they think that relativity is some very complex, abstract mechanics that they understand because they have practiced a lot and everybody else does not. It is not complex at all. It is merely subjectivity. That's all it is. From this subjective point of view, what would your experience be? From that other subjective point of view, what would that subjective experience be? That's all relativity is. It looks like the ground is rushing up towards me. From my point of view, from everybody else's point of view, it looks like I've fallen out of a window and I'm heading towards the ground. It's subjectivity. That's all it is. The halfwit, Christopher, who's talking now, is pretending like I somehow fluffed my question. It's like, no, dude. The reason I was refusing to allow it to be pigeonholed into heliocentric, the old heliocentric model, or the helical heliocentric model. The reason I was refusing to do that was to show everybody how the centripetal-centrifugal relationship only works with a sun that is not moving through space. That's why. C4, I see your comments there. Pay close attention.
And he didn't think far enough into it. So when his gotcha question didn't work, because you asked him to continue his line of questioning, and look, he had nowhere to go. He has nothing left on it. He just wanted to make that distinction. He forgot about fucking reference points in relative to what?
Yeah.
And it fucked him up.
Because guess what? The idea is that Antonio is so stupid he doesn't realize that even orbits can travel through space around and with reference to another object.
Who said that? I didn't know that.
Because obviously you said them within two different equations, dipshit. That's how I know. Because you fucked yourself.
Red, you know that it's going to be hard for you to go to sleep having answered that the sun does not travel through space.
It's going to be hard for you to sleep. Notice that I said that within the reference to within the solar system.
Can I just ask a simple question, and everybody else
clarify?
Antonio doesn't think the Milky Way is in space because you said it does move through space when it comes to the Milky Way. So Antonio must think that the Milky Way is not part of space.
Hey,
Why don't you think the Milky Way is part of the space?
Hey.
He said it moves through the Milky Way and Milky Way's in space, and but you don't believe that's true. How does that feel to have your answers completely just misconstrued and run right up your ass? Yeah.
And somehow overthrow physics with a quote minus sound.
He needs to tell us bullshit to somebody that hasn't been educated in this.
For Christopher, you think the solar system moves through the Milky Galaxy or in the Milky Galaxy?
Of course, I meant the Milky Way.
Well, given what you
see, he was grandstanding about the Milky Way and the solar system, but he was fluffing up a little bit. So I've just pinned him down. Let's see what his answer is.
With the last one, with Red, I'm going to say it moved. I'm talking. Are you listening? I'm saying it moves with the Milky Way.
So not through.
It moves through the Milky Way. No, if it moved through, through would continue in that direction unless captured by some kind of large body that attracted it.
In order to go through something, in order to go through something, the objects, you would have to go through objects. If you're moving with something, then you can still go through it. Like, for example, it's not that. It's not the face of a clock.
He got completely confused then, and he realized that he was just contradicting Christopher, so he kind of quit.
Idiot.
But you have to be careful with Antonio, because if you say you walked through the club, then he could always say, oh, you literally walked through the club, because obviously this is someone who likes to harp on words, and this is what people with no arguments want to do. Why don't you state your argument clearly, and let's talk about it?
Yeah. That's what we're trying to do, but apparently civility is not obeying here. Christopher,
apparently intellectual honesty is absent with yours.
Really dishonest.
Can I have your permission, Christopher, to use your little piece?
Yeah, but I want to point out sure, go ahead. For an hour here, you've asked 3 questions. Why don't you show your face? What's the difference between centrifugal force? And does the sun move through space?
Yes.
Continue your line of questioning. Let's hear it.
Actually, since he asked 3 questions, I would actually like to have the opportunity to ask one.
Hey, how about you answer? Your answer to the sun moving through space.
No, I answered 3 of your bullshit equations, and I actually want to ask something of you. You're the one spouting all the questions. Now I want to ask a question.
Ask a single answer to a single equation.
No, you need to actually listen to a question from me for once.
You need to.
So you want this to be a one-way street? How is that fair?
Why do you keep muting my mic?
Because you don't know how to listen. You don't know how to listen. Okay, then listen to this. Listen to this.
I haven't finished.
So now you don't know how to listen. I'm going to take that part too.
Well done. Well done.
That could have been a perfect moment right there.
Excellent. Now, do you want to arrive at
Excellent.
Do you want to
Now
arrive?
I'm going to ask you a question now.
Do you want to arrive at a conclusion?
I want to get to your answer to my question.
No, you haven't answered mine.
I've answered 3 of yours.
My question. Dude,
come on.
Understand? Right.
Let him get it out.
We've spent 40 minutes listening to him try to get where he's getting to. So
you've spent 40 minutes watching my screen go mute.
Okay, ask your question. Follow it up.
Follow it up.
Okay. I will make it concise. If the body that's orbited is itself moving, and that moving has an arc to it, the effect centripetal versus centrifugal will change depending on where that orbiting body is relative to the body that's being orbited. So it's not constant.
No, you are completely wrong on that.
Can I answer his question, please?
Brilliant. Why don't you demonstrate it by spinning something? And now, let me just change my tone. Because, okay, when I came on, I wanted to come on, Pete was here, and you were showing the feather versus the hammer in the vacuum chamber.
it's volleyball.
Volleyball.
I have
3 hours.
Yeah. So, I have a video of a guy dropping a feather and a hammer in his bedroom. Do you want to show that video?
Is the bedroom a vacuum?
No.
Didn't think so.
No. So, what happens with the feather and the hammer?
Air resistance.
Why don't you play the video?
Because we know it's going to happen. Holy shit.
Yes, we do, don't we? So why don't
the
we
feather's going to slow down because of air resistance.
Why don't we watch the video?
I will play that video after this. And then we will work on the math from Red's data.
He showed.
Why don't we
what's
watch the video and see whether or not what you're saying happened?
And I'll drop the 2 of them here, and hopefully they'll hit the ground at the same time. How about that? That proves that Mr. Galileo was correct in his findings.
I'm moving ahead now sideways. And now, if you'll bear with me, I will play my own footage where I, well, did that same test. Just bear with me. You're going to have to put up with my beautiful, beautiful, rugged, ugly face. Hello, there I am. I'm going to pull up the video. And we'll wrap up that silliness with Red's rhetoric in that debate, which he was so afraid of people watching again that he failed to put it on his channel. Oh dear, but I put it on mine. Oh no. Right, so let me look for my video. It's so funny. So funny when retarded people think that they're clever, and you say, hey, why don't you check to see whether or not you're clever? They go, don't need to check. Oh, well, you know, if you checked, you might first find out that you weren't so clever, but more importantly, learn something that makes you a bit more clever, you know? Now I'm just scrolling through my videos to find the one with the feather. Hammer and feather and scale. And this was really just a redo of Danny Diesel. Danny Diesel did the same video. Here it is. Okay. Wait a second. Pause. Come on. Pause. Good. I'm watching. Yes. Okay. So, that feather hammer drop. This is one of the things that really peed my Globling friends off. I have friends in the real world that are Globlings. Sometimes they fall out with me when I show them stuff that they don't like to see. After having argued with me that it's absolutely impossible, and then I show it and like, that doesn't mean what you think it means. It's like, it means you were wrong about it being impossible, number one. And two, it means what you're seeing. So here we go. Sideways. Even bigger than the one they dropped in space. Bigger? Doesn't that mean more air resistance? Well, yes. Oh, look, let's freeze right there. Let's take a good look, because some people said, oh, look, the hammer's hit first. This is the nearest point of the feather. The farthest point of the feather was just touching my toes there. See? Same pace as you're seeing on your screen. Now prolong that fall, make it 20-30 meters, and then the feather will land after the hammer. Of course. Go to the channel Peter and Pete to see tests proving that conclusively. So let's continue. Oh, sorry, Globlings, you kind of forced to watch this. Oh. What kind of feather is that? A falcon feather! Is it a falcon feather? Is it an eagle? I'm not sure. I forget now. Can you see the feather? Okay. How about that? This is from higher up. Okay, he dropped it from around waist height. It looked like chest height because of the angle of the camera. This is from shoulder height. And you can do this all day long. And I'm dropping it with a feather in different orientations. Okay? Oh dear. It's just, oh, if only somebody had actually bothered checking. See, that's what flat earthers have done. There's all these beliefs, and they remain beliefs until you check them. You can check them and then confirm that the beliefs were based on something true, and then it becomes knowledge. Or you can check them and find that they're not true and they were merely a false belief. But you didn't know whether it was a false belief or not because you didn't check. And flat earthers are guys that have checked and gone, ha, good gosh. There. Need we say anything else? There. I'm weighing the feather 6 grams. And the hammer, 787 grams. Oopsies! Oopsies! So, let me stop sharing that. Poor Red. What we're going to do today, just bear with me, I'm going to sort out channels. What I'm going to show. We're going to go and use his data and work with his data. Okay? We're going to watch a portion of his video, then we're going to go to some other videos. Let me just see a second. We'll go to his original video and we'll look at that. Okay? But we'll also correct him in a couple of things that the poor Dim Dim just doesn't realize. So, let me screen share again. And we will work with his math. Okay? Absolutely 100%. His data. That's what we will work with. So let me screen share this. And we'll listen carefully. Globlings. Okay? Make sure the volume is up. Okay.
So we will go ahead and use a scaling triangle for this example. So this was the challenge. Now, I will tell you how I would solve this problem. There may be other ways, but the way I'm going to do it is perfectly legitimate, and it's just by doing grunt work.
Oh, grunt work. We'll see how legitimate this is too, okay? Okay.
So the first step would be to bisect this scaling triangle into 2 right triangles.
Oh, this is where I'm going to stop screen sharing. In fact, I will play that again, okay? Just pay close attention, Globlings. I'm doing this for you. Listen carefully.
Is perfectly legitimate, and it's just by doing grunt work. So the first step would be to bisect this scaling triangle into 2 right triangles. Now
You can't. So what I'm going to do now is I'm going to show you, plain as day, his triangle was like so. Okay. This is bisecting. The way to bisect a triangle really is to take any of the sides, find a midpoint like here, and extend a line to the opposite angle. This is bisecting, okay? And this is bisecting a scalene triangle. This is his and Astronomy Live's scalene triangle. This is a representation of what they thought they were working with, which is not what they were working with. What they were working with was worse than this. That's what we'll do the math on. But first, you'll just have to bear with me while I show you what Red thinks he's doing with his bisecting of a scaling triangle to arrive at two or further scaling triangles with a right angle. Okay? So I will just quickly draw a simple scaling, not this, which is his. Okay, see how this is more than 90 degrees? That's why I've got the red line. That's more than 90 degrees. That was Astronomy Live's angle to the ISS. More than 90 degrees. Okay? Sorry. So I'm now just going to draw a simple, quick scaling triangle. That's not as warped as the one that is a representation of what they were working with. And you can do this at home. You can show your children or your colleagues at college. It's a scaling triangle. Jolly good. Should we bisect that? Yes. How should we bisect it? Should we just arbitrarily choose a point so that we'll have a right-angled triangle? Or two right-angled triangles? Well, no, that's not how you bisect a triangle, silly. The way you bisect a triangle is you find the midpoint. So let's say there, and this is done by eye, but you can check yourself. Take a screen grab, okay? And then go from there to the opposite angle. Okay, so we're going to go from there to the opposite angle. Oopsies, not a right angle. Do you see? Bisecting in mathematics, geometry, means literally cutting in half. Not this biological term, which means basically dividing into two pieces. In mathematics, it means equal, either equal length or equal area. Okay? Let's look at Red's and see whether he has either equal length or equal area. Let's see if we can determine just prima facie, okay, at a glance. Oh gosh, we can definitely see that's not bisected, and those are not equal area or equal length. But let's continue with a poor dim-dim.
I know Antonio says you can't bisect a scaling triangle into two right triangles, so...
That's right. That's what I've just shown. And what I was showing on the screen there was what Red did, which is not bisecting a scaling triangle. And if you look at the text, I'll highlight it. An evidence-supported logical argument can be made anywhere. That's right. That's what somebody had written. Okay, that's right. Here is evidence showing a lack of logic. Math is fun, and I'm quoting, math is fun. Bisect means to divide into two equal parts. You can bisect lines, angles, and more. The dividing line is called the bisector. Let me repeat. Bisect means to divide into two equal parts. That's maths. In trig, is it trig math? Yes, you cannot bisect a scaling triangle into a right triangle. Okay, but the poor dim-dim, even though he's highlighting that, has not taken it on board. He has not understood. And he shows that he doesn't understand by dismissing it and continuing as if, no, it doesn't really matter what math says. I want math to say this other thing, so I'm going to pretend that math says this other thing that I want math to say. Oopsies.
Here is an image where he says you cannot bisect a scaling triangle into a right triangle, and then here's a screenshot of him on camera bisecting a scaling triangle into two right triangles.
He still hasn't grasped, see what I mean? He has not grasped the fact that you cannot bisect a scaling triangle to make a right angle. You just can't. It's just not doable.
Here's the definition of bisect that we're using for the word divide into two parts. Hey Antonio, did you divide this triangle into two parts? Yes, you did. Thanks, Antonio, you fucking dipshit.
Okay, so now I'm going to show, just for the Grobelings out there who are having a little bit of a mind glitch right there, I'm going to draw another triangle, just bear with me, and I'm going to separate that into two parts, which is what he just said was the main thing. Okay, so it's two parts. Wonderful. I'm going to take another triangle. This time I'll lean it over this way, and I will divide it into two parts. And it's tragic to show this to well, to have to show this to people who ought to be intelligent enough to be able to figure this out without anybody showing them. Okay, so what I'm going to do is I'm going to, let's see, yeah, I'll do it like this. Okay, I'm going to separate the triangle into two parts. There you go, there's a triangle separated into two parts. Does that count? No, it doesn't really, does it? Should we see about separating it into a right angle triangle, just completely arbitrarily? Yeah, let's do that. So we're going to forget now the line that I just drew. We're going to pretend like that wasn't separating into two parts, although it was, okay? And let's drop that there to make a right angle triangle. Let's just do that. Let's just totally arbitrarily do that. That's right. Yeah, because then we can just divide the angle. We can see what portion this is of the whole line, and say it's a quarter. Let's say it's a quarter. Then we can just divide the angle by a quarter and attribute a quarter to this triangle. Yeah, because we can just do that. Wow. So let's go back to dim rhetoric.
Anyway, so this is the challenge. So let's go ahead and solve this challenge. Now, the way that I would solve this challenge, the way I would figure out length A and length B is by plugging in arbitrary values for length C and
arbitrary values? Oh, jolly good.
Finding out what the angle would be at the end of the equal sign. So let's go ahead and do that, shall we? So what I did here is I added just a few random pieces of information for x here, and then x here. This last part right here is not arbitrary. 524.73 kilometers was the value originally found in my video, the ISS finding the altitude.
Nah. That was a rationalization for that distance. And I will show it again with triangles, with geometry. Can't always say triangles, especially if you don't have a triangle. I will show it with geometry, and then I will show it with math, and we'll show what Red actually showed with the data. The only data he actually has is the length of the baseline. That's the only data he has.
So we know a few things. We know that our baseline must equal 1,099 meters. So we have here 0.664 kilometers and 0.435 kilometers.
Okay, sorry, just need to make a note because apparently it's now 1,099 meters. It used to be 1,111. It was also 1,011. Okay, that's interesting. Oh, okay. We'll just tweak things however we must.
Kilometers. And here's the thing. We can once again shift this line anywhere we will like. The angle for alpha is never going to change, and therefore the result is never going to change.
Exactly. And you could do that with any triangle you liked, although you couldn't have used that triangle to determine the values. If you concoct the values, if you just say, look, these are the values, now let's process that through a triangle. See, this is math. You can say that 3 plus 1 is 4, that 2 plus 2 is 4, that 1 plus 3 is 4. You can say that 1 plus 1 plus 1 plus 1 is 4. If you've already arrived at 4, it doesn't matter how you arrange things. It's going to be 4. It's mathematics. It's very simple.
But let's go ahead and continue anyway. Let's assume for a second
Let's assume
that this value x right here equals 21.336 kilometers. Let's say...
No, let's not. Instead, let's go to his previous video. I think it's the love triangle. I think it's that one. See, he's changed his triangles several times. Let me just make sure I'm displaying what I think of display. Yes. Let's go to his original. Here we are. Okay. I showed this yesterday. I showed how the azimuth demonstrates they did not have a triangle to begin with. Oh dear. I would play with that geometry. We will then play with their baseline, which was the only datum they had. Moving ahead. I'm going to move ahead. They have the transit. Jolly good. Very good. Aha. So, let's see what Red did to derive those values. Okay. Considering, one, they did not even have it. Here, I'll show it. I will show it like this. Where's the drawing? Look. This was their situation. Okay. Here was Astronomy Live. Here. And here was Red. Okay. What they had, I'm going to draw it just quickly here. In fact, no, I will use the whiteboard later. Okay. This is what they had. Okay. That's what they had. That's not a triangle. Silly. Okay. It doesn't matter that the path of the ISS supposedly, which didn't quite fit Red's observation, and we'll go over that again, okay, was like this. It doesn't matter. You can now drop a vertical line from that all you like. Can you see it's not going there? This is what they had, okay? Okay. Let's see what they did. Did they use this? No. Did they use the scaling triangle that they did have? No. What did they do? Well, we'll see.
Myself and Astronomy Live. You will see...
Huh. That's what they did. That's interesting. It's got nothing to do with their observation. In fact, you could do this at home without even going out and looking at the ISS. You really could. So let's go.
In this diagram that they cross at the International Space Station, and as they continue, they end up on different parts of the moon.
This is called parallax. No, sir. Okay. If they cross at the ISS, then this is what you would have. I'm going to now display me again. I've shown this before. If their lines of sight crossed at the ISS, what they would have is this. Watch. It's very simple. Okay. You have the ISS with its panels. Okay. It's a TIE fighter. Oh, it's very funny. Okay. ISS. Like so. Their sight crosses at the ISS. That's the peak of their triangle, apparently. Wonderful. In which case, what they should have, if they were to take the image and superimpose it, okay, well, this would be the ISS, and it should look something like this. Okay, that's what I'm going to do now. I'm going to draw a circle for one observation. give or take, and a circle for the other observation. This is what they would have. You see, they've just superimposed the ISS, and well, on this one, the ISS was on this side of it, and on this one, the ISS was on that side of it. Jolly good. Except if you do this, you can't really do the rest of the math. It becomes more complex for them. Okay? So they didn't do this. Instead, they just worked on this. What their triangle, which is an invented triangle, is representing is this. One path here and one path there. That's what their triangle is representing. Which means that the midpoint, or the apex of the triangle, is not either this line or this line. It's instead a center line across the moon. Okay, that's what they're doing. Okay, interesting. Let's carry on. I think we might see Santa Claus there too.
Parallax is the exact same thing when you look at your finger with one eye, and then by switching to the other eye, your finger appears to move relative to the background. Now this is useful because it allows us to do a few measurements. So let's go ahead and find angle A in our diagram. And
you can't find angle A in your diagram. But let's continue.
Since angle A equals angle B,
that's true, angle A does equal angle B, but you can't find angle A. I tell you why you can't find angle A. Look. Look, red, and look, Globlings. This was the actual observation, okay? You can't find angle A. Do you understand? So this was the distance between them, and this was A and B, okay? X is the distance between them, and this was A and B, okay? That's not a triangle. It does not make a triangle. You cannot use it to triangulate. Jolly good. You can say that you did, and say, look, so look, with this triangle we can derive these values, but that's a fabrication. This is it's called, in science, it's called fraud. That's right.
We can knock out two birds with one stone. Now the moon is a certain size in the sky. The size it appears to us here on Earth is called its angular size. Now my friend Astronomy Live measured it directly on the same night we filmed the transit. If you wish to see his calculations, his video will be linked down below. But for this video, a simple search on Google will do just fine. And according to Google, the moon is about 0.52 degrees wide as seen from Earth. With that in mind, let's overlay our two tracks together. With this, you will see that our two tracks span a certain amount of the moon. In counting the pixel diameter from Astronomy Live's footage, we find that the moon is about 962 pixels wide. The span of our two tracks from center to center is about 224 pixels wide. If we take 962 and divide it by 224, we get a ratio of 4.29 to 1.
That's important. 4.29 to 1.
So, if we take the angular size of the moon as 0.52 degrees wide, and we divide it by the value we just found, which is 4.29, that means that angle A in our diagram comes out to 0.1212 degrees.
Wait a second. 4.29. That means the separation, so if we were to take the space between the two red lines, wait, let me display it in a different way.
Two tracks from center to center.
Oops. Okay. Now, this way you can see my cursor. If we measure this distance, and we see how many times this distance would fit across the diameter of the moon, we'll find that it's 4.29 times. Very good. Let's use mathematics. What is this distance representing? where did I write it down? Was it 1099? 1099 meters. Let's do some math. Let's see what red showed. So 1099 was their baseline. That's the distance displayed by that red line between the two vertical lines where it says 224 pixels. Okay, that represents 1099 meters. Let's multiply that by 4.29, okay? 4.29 equals 4,714 meters. Meters. 4 kilometers. Let's look at the moon's diameter. Let's see if it's 4 kilometers. Oh, wait a second. Oof, it's not. Let's see. Oh, misspelled this, sorry. Moon's diameter in kilometers. Oh, wait a second. The moon's diameter is 3,474 kilometers. What did our math just tell us? That it's 4 kilometers. Can you see? According to Rhetoric, from his data, the moon is 4,714 meters in diameter. That's one thing that we can definitely say his data showed. To argue with that, you'd have to say, well, if that's the case, then the moon would be at the same distance as the ISS. Yes, that's exactly what this will be saying. With the moon at the same distance as the ISS, the moon's diameter would be 4,000 meters. That's 4 kilometers. 4.7. So just over 4.5 kilometers. But it's supposed to be 3,500 kilometers. But it's 4.5 kilometers. Obviously, the moon isn't at the same distance as the ISS, is it? No, of course not. Where is the moon? How far away is it? Let's look at our Bible, shall we? Huh? Let's look at our astronomy Bibles and see what it tells us about the moon. Do you see, Clublings? I told you I was going to show the math. There's the math. You just saw me go through it, didn't you? Let's continue with red. Did you see what I just did? Okay, the line between those two red lines, which are tracing the ISS for both observations, that plays a role of 1,099 meters. Okay, in that case, the moon is only 4 kilometers wide. 4.7 kilometers wide. Thank you, Rhetoric. Maybe the Flat Earth Society will take this information that you've very kindly given to them, and they might start saying that the moon is only 4 kilometers wide. Maybe, I don't know, up to, I think, last I heard, they were saying that it was 300 miles wide, or something. I don't know, I don't keep up with that gibberish. But we just saw it here, didn't we? Let's continue. See what red did.
Center is about 224 pixels wide. If we take 9...
Wait, let me display in a different way so I can watch the chat.
62 and divide it by 224, we get a ratio of 4.29 to 1. So, if we take the angular size of the moon as 0.52 degrees wide, and we divide it by the value we just found, which is 4.29, that means that angle A in our diagram comes out to 0.1212 degrees. And
that would be if they had a triangle for their observation. You see, you can't have an angle at the apex there if you don't have a triangle. But we've seen they didn't actually have a triangle. So what did they have? They had line of sight observation of the ISS telling them that the moon is 3,000 meters, 3,500 meters, was it? I forget. Let's look at the... Oh, sorry, 4,700 meters in diameter. Ha, that's drastically different to what the globe says. That's the only thing that they can really establish. That from their observation, the moon would appear to be 4,714 meters in diameter. Well, how close would the moon be to be... well, the whole thing breaks down, doesn't it? It does. Now we're going to listen some more to Rhetoric, and then we're going to use Rhetoric's own video and the real world with the azimuth as presented in yesterday's hangout to show absolutely that they were not working with a triangle. You cannot triangulate without using a triangle. You might take the word triangle from the word triangulate as a clue. What do you need to triangulate? A triangle. That's what? It's kind of easy, really. Let's listen to Red.
And since angle A equals angle B, that means
this angle doesn't exist. In the real world, they did not have a triangle of any form. But if we had a triangle, then... well, you didn't have a triangle, did you, Dim Dim?
B is also equal to 0.1212 degrees. Now that we have angle B, we now need to find our baseline.
But wait a second. You already had your baseline. That's the only thing you had. You didn't have your angles, which are absolutely necessary for triangulation. Let's look again at Wikipedia telling us that. Okay, triangulation surveying for looking at things in the distance. Right there, okay? Triangulation may be used to find the position of the ship in this illustration or a distant object, okay? When the position of A and B are known, so A and B, that would be Rhetoric and the other guy. Good. An observer at A measures the angle alpha, while the observer at B measures beta. Remember that in triangulation, only one angle is measured. What does this mean? That you're not measuring elevation. Only one plane is being measured. Okay, only one angle. Okay, jolly good. Now, the position of any vertex of a triangle. What's a vertex? What's a vertex of a triangle? What's a vertex? It's the point where it's the apex. It's the opposite end. Okay. The position of any vertex of a triangle can be calculated if the position of one side and two angles, that would be one side, the distance between them, Red and Astronomy Live, and two angles. Which two angles would this be? Would this be Red's angle and the right angle? Or would it be Red's angle and Astronomy Live's angle? Used to establish a midpoint for a right angle. If you don't have a right angle, you can't do it. It's relating to A and B. Two angles. Known, not the right angle, which is hypothesized. You understand? It's telling you this is how you triangulate. You need two angles. Did they have two angles? No, they didn't. They didn't have a freaking triangle to begin with. Okay, and the following formulas are strictly correct only for a flat surface. Jolly good. We will also discuss what it would mean for their observation to have taken place on a curved surface. If the curvature of Earth must be allowed for, then spherical trigonometry must be used, and the following calculations, the equations you're looking at, are not spherical trigonometry, it's plane. Okay, so with L being the distance between A and B, we have L, so the distance equals, L, distance being the distance divided by the tangent of A plus the distance divided by the tangent of beta. Using the trigonometric identities, tangent A equals sine A divided by cosine A, and sine alpha plus beta equals sine alpha cosine beta plus cosine A sine beta. This is equivalent to, and there you go. Okay, you can do that all day long. The dash just means divide. Okay, the plus symbol means plus. The equals means equal. Okay, it's not that complicated, guys. So, let's go back to Red, who didn't have a triangle, and said, well, if we had a triangle, we would have this. Let's continue.
Our baseline is the distance between myself and Astronomy Live. For this measurement, we will use Google Earth. Measuring this out gives us a value of 1.11 kilometers apart.
Very good. 1.11 kilometers. Well, that's not 1,099 meters, but never mind that. We will now go into yesterday's Hangouts, where I also used Google Earth. I mean, they used Google Earth. They could have gone on to use Google Earth once they plotted that line. They could have used Google Earth and, well, drawn the heading to the moon. In fact, they could have plotted on Google Earth the path of the ISS, just like I did yesterday, and I'm going to present it again now. So they could have done that. Did they do that to establish their angles at least? No, they didn't. No. Well, why didn't they do that? Because the real world does not conform to their ideas of it. And if they checked the real world, they'd have to dismiss their ideas of it. That's why. Okay, so bear with me while I pull up yesterday's Hangout and play the part where I did actually bother to, well, plot those things on Google Earth correctly. So just bear with me. Ay. This is so much fun. This is... Oh, apparently, I owe an apology to Astronomy Live because that was not him swearing. Okay. But then I will just say this. That's according to him. And he's demonstrated that he lies and has a problem with reality. But just in case that in this situation he's not lying, I will apologise. It was not him. According to him, it was not him swearing. Okay, so it was not him swearing. Let's take that at face value. So just bear with me while I pull up yesterday's Hangout. The part of yesterday's Hangout, which is, well, the parts of the Hangout that's related to the real world, was absolutely dismissed by Red's Rhetoric. I'm going to play it again. Maybe he can dismiss it again and just say it's irrelevant. Angles, irrelevant. Which is what he did. He literally said, the azimuth, irrelevant. Like, wait, aren't those angles for your triangle? So I'm pulling it up. Just bear with me. Let's see. Okay, here.
The display.
Okay, so now I'm going to replay a portion of yesterday's Hangout. I mean, this is just so easy. It really is. Like, I don't like the expression shooting fish in a barrel. It's like, dude, if you've got them in the barrel, what the heck are you doing shooting them? Just leave them in peace. Get them as you need them. But hey. Yeah, this will do.
Okay. And I'm going to go back here.
No.
You would get
back to...
I will do a different display. This display. That way I can join you in the chat.
Mooncalc. to show this situation here, which was 234 to the moon, which is where the ISS transited, and I think it was here, yes, this line, which is where the ISS was transiting the moon. So I'm going to now verify that with Google Earth. So here we have Google Earth. I'm going to roll it over to Florida.
Alert! Alert! Globe link! Pay attention! Alert! Alert! Globe link! Pay attention! Take your eyes off the chat. Ignore that you're getting owned by stupid flat earthers. Just ignore that. Pay attention to what's being shown and then ask yourself why Red did not bother showing you any of this.
And I'm going to quickly zoom in over here and show what I have. This line, this is where they were making their observations, and I'm going to go back here and show that this was indeed the case. Just give me a second while I scroll in this video. There's a point where he shows this here. Okay, so this is what I have plotted here, and anybody can go and just pay attention and plot the same. Okay, so now I'm going to pull the ruler. I'm going to put it to meters, and I'm going to zoom in a bit. I'm going to go here, and this is just to show the distance between them. Oh, wait. 1,123. That was their actual distance. They think, and they say, that their distance was different to that. They say it was 1,011 meters, but that's not. That is really neither here nor there. This line here is the line of the.
That distance, by the way, it now turns out is 1,099. Oh, okay.
I'm going to grab this here. And now we're going to look at the heading. If you look at the heading over there, you see it's 222 degrees. That's the path that the ISS was at. From here, the ISS was at, oh sorry, I dropped it wrong. From here, which would be their so-called center line, it's 122 degrees. Okay. Now, I'm going to go to the position where Astronomy Live was. I'm going to just trace this red line. It's 234 degrees. That's correct for an observation of the moon. Okay, you can see right there at the top left of your screen, that's 234 degrees. That's great. Now let's go over to red. It was here. Wait a second, I think. Oh, lines follow the contours are fascinating. Again, 234. There's a small separation, but don't worry, that's more to do with the orientation of this, the program. 234. Okay, let me do that again for the, in case there are any doubts. Okay, 234, which is right for an observation of the moon. Now, I'm going to pan out and just point something out. You remember where Astronomy Live explained about making their lines perpendicular to the transit line? I'm now going to draw, just quickly, what they were aiming for, which was a line perpendicular to this, which would be from here, and I'm just going to do it roughly, would be something like, it's difficult to do because we're at an angle, but it would be something like this for him, and from Red's position it would be something like roughly like this. That's because they're not at right angles to the path of the ISS. So their triangles were based on, well, an entirely different observation based on this 90-degree situation here, a situation they did not have.
So I'm now drawing a 90-degree angle, which is what Astronomy Live did. He said, well, from my point of view, to the path of transit. If I make a 90-degree, a right angle triangle, and if I do the same for Reds, and if, then if... This is why they did not take into account their azimuth to the moon. This is why. It messes the whole thing up. It splays their almost parallel, their diverging directions to the moon. Not to the ISS, to the moon. Diverging. And diverges it further. That's what doing this does.
Now, I'm going to zoom out and highlight this line and this line. You might have noticed, some of you, that there are two lines here. That's because well, you'll see why. It was pretty tricky. Okay, from here, I'll just grab here. I'm going to zoom out and go, well, all the way out. And all the way out to here. I'm going to turn that into kilometers. It's roughly 315 kilometers. This is the ground distance to the ISS.
Oh no, Antonio, how did you work that out? Well, I follow the instructions on how to find the cosine of such an observation. It's kind of simple. That's the distance. That's the ground distance to the ISS. Oh, okay. So that would be the point where on the Earth you would have looked directly up into the sky to see the ISS. Does not mean you would have also seen the moon. Okay, you would have just seen the ISS go directly over your head, according to Astronomy Live. But wait a second, see that other red line to the bottom that goes, well, it's pointing more down? That was the path of the ISS. Shouldn't the ISS have been somewhere along that path when it was 315 kilometers from their point of observation? Well, it should, but it wasn't. Oh no, well, you just can't use azimuths, okay?
I just grabbed one of the observer's lines. You can see the other observer's line, just underneath it, it's the red line. When I zoom in, you'll see. Okay? That's the other observer's line. This other line here is the ISS's transit line. this line is the ISS's path. This means it would only really, given this spherical world that they think they live on, would only really be possible to bisect the ISS's path if it was here. Just there. For this observer, which would be Astronomy Live, you see, this is the path of the ISS's transit. I showed this when I turned over to Google Earth. I plotted this as it's plotted on their map shown by Rekt's Rhetoric. I'm going to show it now, and I'm going to show a few key points to keep in mind. Okay, so I have to scroll back to here. Okay, so we're now plotting this line. This is the line I've plotted, this is the line we're now confirming. First, we're going to look right down towards the bottom. There's a small pond here. It goes just over the top. A bit. Just there. Okay. It meets this road at the corner. Okay, so I'm going to expand. It meets this corner. Having come through here, missing this pond, just past this corner, entering here, touching this corner, then this corner, then across to this pond. Okay? So again, it comes across here, enters here, there's a corner there, there's another corner here, another corner. So that's what we're looking for.
Pay attention, Globelings. This is a map of the Earth. Google Earth is supposed to be a more accurate representation of the Earth. So if you plot this on Google Earth, it should be an accurate representation of the transit of the ISS.
Google Earth. So here's Google Earth. It comes across and meets
There's one triangle there.
this corner, and goes across to this pond. You see, this is pause. This pond. That's what I've just shown. What I have shown is this line, except instead of on a flat map, I placed it on a globe, which is Google Earth.
Why does Google Earth keep messing things up for you, Globelings? Why don't you ask yourselves that? Why does Google Earth, whenever you try to plot anything accurately and you go to plot it on Google Earth, why does it mess things up for you? Look at what it does to the path versus their observations.
That's the path, like the real path according to Google Earth. When you take the map telling you where the transit would be, the nadir of the transit would be along this line. Precisely where I've just shown, where I've plotted it. These were their observation points, here and here. Now I'm going to show, if you care to look at the heading, again, that this would be at 222 degrees. The moon was not at 222 degrees. The moon was at 234, which means if you'd been here looking for the transit by following this line, you would have missed it. You must instead look towards the moon, which would be 234. So I'm going to take this to 234. Okay. That's the direction to the moon. That's the direction for Astronomy Live to the moon, 234. That's the direction for Rekt's Rhetoric to the moon, 234. This is the path of the ISS. absolutely impossible for Red's rhetoric. The yellow line that I'm pulling now is Red's observation. And we're comparing it with this line here, which is the ISS's transit through the sky as it crosses the moon. At the distance that Astronomy Live said the ISS was at, we're talking this distance between Red's aimed camera and the ISS. That's what we're talking about. That's how much of a discrepancy we're talking about. 63 kilometers. Red would have missed the ISS by 63 kilometers if the ISS was on this path. Now, they captured the ISS in front of the moon. In the real world, they really did capture the ISS transiting the moon. They didn't bother checking these angles, see? This angle here was not checked. This angle here was not checked. Now, if we go back, where was it? Give me a second. If we go back here, we remember that you need, once you have a baseline, you need two angles. You need two angles. Those would be...
That's it. That's it. You don't need to say anything more than that. Now, according to Red's most recent hangout, you don't need those angles. They're irrelevant. We can just back engineer from fantasy, just make triangles that are impossible in the real world. Just concoct them, not just ignoring the real angles, but refuting the real angles. The real orientation to the moon, your orientation, so your azimuth to the moon, we can just entirely ignore that. It's inconvenient for us, so let's ignore it. That's literally what he said. Don't need the azimuth. Oh, really? Then you at least need to aim to the moon? Yeah. What is it you're using to aim to the moon? Well, obviously the moon, but maybe you should check your data and find that you're aiming at 234 degrees. And there's the moon. Jolly good. You're aiming at 234. He's aiming at 234. Unfortunately for you, you're on a curved surface, supposedly, and you're not quite both aiming at 234. You're aiming at just like a fraction different because of your difference in location, and that fraction splays your line. It doesn't what's the word? Converge it. It doesn't bring them together. Splice it slightly. You could have just checked. So, now I'm joining you in the chat. I see C4. Hey, you strange person who somehow has a wrench in a Ice to Seas hangout. What's the deal with you? Yeah, interesting cookie, aren't you? So, I'm now going to read, where is it? There's a guy who's got a problem with language, and of course, being a globeling, he projects that. He's claiming that I said that I didn't want a hangout with him. And now, I said, we're going to have a hangout, just Red and me, on this channel. Later, Red said, no, you and me on this other channel. I said, okay, well, let's up that, and you and me on Sam and Dan's channel. How about we do that, okay? Red's like, no, you're just trying to go for popularity. Why would we go for the one with 100 and odd thousand subscribers? You only have 2. Let's go for the one with 10. I was like, well, if less subs is what qualifies people more, then let's have it on mine, because I have even less than 10. See? Also, I had about 20,000 when my channel was pulled. Okay, so let's not be silly, Red. I had more than you when my channel was pulled. That's right. Anyway, So, there's this person in the chat, friend of Red's, saying, Antonio said he didn't want me on the panel. I said, no, I didn't mention you at all. I said, no, stop lying. So, like, when did I lie? I didn't lie. You said that, and it means the same as, well, no, you said I said you. I didn't say you. I didn't mention you at all. Dude, arguing with you is like arguing with Gem Panda. You really are that level of stupid. Like really. Anybody who listens to you can see it in 2 minutes. At the Book of the Sun, I gave wrenches to a couple of Globerers who weren't quite so obnoxious because people were calling bias, level playing field thing. I see. I totally see you. I gave a wrench to what's his name, Rock Lover. When I gave everybody wrenches, I gave wrenches to Globlings too. You know, so yeah, I get it. But he's still a funny cookie. C4. Anyway. Oh, where's Wally? That guy. Let me see. Just give me a second. Somewhere I have a torch. Yes, I have a torch here. I'm going to show you a really amazing experiment, and it comes thanks to Where's Wally? Okay, how should I do this? Let me see. Yes, I know. Here I have a band, you know, an elastic band, you know, as you might put in your hair. You've got long hair. What I'm going to do is I'm going to twist it on my finger like so. Okay, can you see? Right, I've twisted it on my finger like so. I'm just rolling it up. Okay, and what I'm going to do is I'm going to bend my finger like this. Oh. Right, and this is actually, wait a second, I will use something red. This guy, the desperation in these Globlings is so palpable. Okay, so here I have a red band. Okay, so I'm just going to do the same thing. I'm going to twist it on my finger. Okay, no magic trick, nothing like that. Okay, right. I'm going to bend my finger like this. Okay, and what I'm going to do is I'm going to illuminate it like the sun was up there. Okay. This is playing the role of the Tesla Roadster's paint job, okay? We're going to pretend that the sun is up there in Where's Wally's model. The sun is in that direction, okay? Somehow the light from the sun is going to not hit the band, okay? Watch. This is now going to play the sun from Wally's example. This is not a joke. You can go to his channel. Okay, look. Can you see how now it's illuminating the tip of my finger? But it's not reaching the orange. Can you see now it's reaching the orange? Okay. So what I'm going to do is I'm just going to move this and angle it like this so you can see more. Okay. Angle it slowly until it, oh, can you see how it's reaching a little bit? Okay. That's what Wes Wally has done with a torch where he's supposed to be replicating this. That's right. The sun directly. You see how it's kind of shining on the band? Yeah, no. Wally thinks that you can replicate the sun by doing this with a torch from this angle. The sun that's in that direction. That's Where's Wally in the chat right now. In fact, what I will do, I've got about another half hour before I wrap up. I'm going to play you that video of him doing that. We're finished with Reds, by the way, because the guy's just finished anyway. So, 4,714 miles in diameter, the moon, according to Rhetoric's data. Rhetoric has proven that the moon is 4,714 meters wide. Apparently. You know, he could do the same thing with a rainbow. That's interesting. He could do the same, take two observations, a rainbow, two observations, and have something fly in front of the rainbow, work out the degrees, and work out the diameter of the rainbow. Oh dear, he might arrive at... If he did that, and he used the same triangle, he might arrive at exactly the same distance that the ISS was from the moon. Good, as long as he uses the same triangle. Right, so now I'm going to play Where's Wally, that half-wit. Alright, wait, before I do, I'm going to read this. Dim Dim 82 Productions. You were off base on what I was referring to, Antonio. I was talking about days ago. And you did say that you didn't want me or anyone other than Red. Where did I lie? At the Book of the Sun. Go and find the part and quote it. Exactly, 82 Productions. I'm going to time you out so you get time to do that. Go ahead. And now I'm going to go to Where's Wally's channel. It's just fantastic. I see you've gone quiet in the chat. Where's Wally? What's wrong? You might want to ask Wolfie, when is he going to make that video of the of the gyroscope? Ask Wolfie, when is he going to make the video of the gyroscope showing apparent drift appropriate for his location? Right, let me see, is this the one? Yes. Oh my god. This is just so priceless. What you're going to see is an adult trying to replicate the sun being at, let's say 45 degrees. You know, let's just be vague. About 45 degrees. That's what you're going to see, okay? Just bear with me. An adult, bear in mind. Now that's me. Let's play.
This is Where's Wally trying to explain how right now you can't see any red.
He literally said at that part of the video, and that's why you can't see any red.
Well, Antonio, that is the before shot, so I guess I probably was trying to show you that the vehicle was red at that point. You know, I kind of saw it later where I thought, well, Antonio won't be that intellectually dishonest, will he?
As to point out that it's red, whilst you were literally saying that's why you can't see any red.
Well, the torch that he's got, he's aiming it above the car so that only the fringes of the beam are reaching the white paper.
You know, like I just did with a torch right here on this very hangout with a band on my finger, like that.
That's what he's doing, because the sun can do that in space too.
Okay, Antonio, so now you did actually think that it was only the angle of the torch and I was just hitting it with the edge of the beam. Man.
So let's do it again from a different angle. You'll never be able to tell that that's what I'm doing. Watch.
And you're going to read it and weep when you see what I show you next.
Wait a second, we don't see the shadow of the camera on the car. Wasn't just like the Tesla, was it? It was, you didn't have a light on your head.
This is just like giving a person enough rope and waiting for him to hang themselves. So now he thinks I didn't have the shadow, the camera behind. Well, I put the camera behind and I put the shadow on it just for you, Antonio.
In other words, acknowledging this is just like that, the mentality that Astronomy Life has. I did not flip the image. I did flip the image. I've unflipped the image. I didn't flip the image, and it wouldn't even matter if I did flip the image anyway. That kind of mentality. I pointed out, oh, you're not very bright guy. We can see it's not behind the camera because there's no shadow from the camera. It's like, oh, he says there was no shadow from the camera? Well, I'll show you. I'm going to put the shadow. Thank you for acknowledging that what I was saying was true.
Man, you're going to love this video.
The beam's not falling on the car. That's why you can't see the red.
What Antonio failed.
That's what he was saying at that point also. You know, the beam's not falling on... You can't see... Let me go back. You can't see any red... These are not the droids you're looking for.
On it just for you, Antonio. Oh man, you're going to love this video.
Here, you can't see any red. These are not the droids you're looking for.
The beam's not falling on the car. That's why you can't see the red.
What Antonio failed to do, but of course I did do, was actually go and do the test, even though I'm doing it again.
Can you see the shadow from the camera? And can you see it's falling on red paint? Because, well, the light is showing that it's red paint. Entirely unlike the Tesla Roadster. Okay, let's carry on.
Okay, so this time I put the shadow so it does shine over the car, Antonio, so you can see that the light is clearly right behind the camera, just like it was on Starman. And guess what the highly polished reflected red car is doing? It's letting the light reflect away. Now it doesn't
You can see that it's red, can't you? Yes, you can.
just slide off like you straw man, it actually reflects off. And now if you lift the light high, you can see, oh look at that, and you drop the light low and then...
That's right. You see, when you put the light high, that's where the sun's supposed to be in the Starman footage, and we should be able to see, well, the paint quite clearly, like when you put the light up high. Let's watch again.
Slide off like you straw man, it actually reflects off. And now if you lift the light high,
If you lift the light high, that's right. What about if you make it about 45 degrees shining directly onto the car?
you can see, oh look at that, and you drop the light low and now you can't see again, the red goes black.
That's right. This is an adult, by the way, who calls himself a scientist, okay? That's true. Like, Wes Wally says that he's a scientist. He knows people in Antarctica. They're scientists too. They're at the South Pole. They're scientists too. Look at this 24-hour sun footage from them. It's not tricked or anything. It's not from the North Pole and reversed. No, silly, no. This man calls himself a scientist. He's supposed to be replicating the sun shining on the Tesla Roadster, and he's showing, well, here's when the light's coming from below, and here's when the light's coming from above. It's like, you're supposed to be replicating the sun, and the sun's not going up and down, and the Tesla Roadster was also not going up and down.
Did you notice those little red bottle caps? They're not going black. I wonder why. Can you...
Like, really, I'm not joking. I'm going back frame by frame. I've shown this before. When he says, can you see how the red cap is not going black? It just so happens to be at this point where it's gone black. That's the level of broken that this man is. Can you see how that red cap that was pretty much in the center of the frame is not visible anymore? That's right, because light's not falling on it. Just when he's saying, can you see how the red cap is not going black? Listen.
Did you notice those little red bottle caps? They're not going black. I wonder why. Can you answer?
Like, literally black on invisible cap.
So that one, do you know?
I don't know.
Can you see those?
I don't know.
And then I walked around the back of the car and oh, look at that. Oh, didn't expect to see that, did I?
Very interesting.
Okay, here's where Antonio fails a little bit more. He's going.
So, the lights from the sun would be behind us and up. Okay, not behind us and down, but behind us and up. Where would it be falling on the car? Well, on the car, just like it's falling on the Earth.
Going to show us the black car in space with the blue Earth behind it, and he's trying to work out why we don't see blue light reflecting off of a red car.
No, he
but
isn't.
of course we do see the...
Look, silly. The light that would be coming from the Earth would not be blue light. It would be white light. Okay? It would just be light, and it would be illuminating the car. But never mind that. That would be nothing compared to the sun's light falling on the car.
The white clouds reflecting off it. Blue coming off of red. I wonder if Antonio, the artist, can figure that out.
we can see the Earth's reflection
We can see the sun on the wing mirror and the helmet.
on the car. Somehow, the Earth's light is not showing us the car's colour.
That's so. Where's Wally? Here's a test for you. Get yourself a nice big poster of planet Earth, just like there. Okay, a great big poster of planet Earth in space, you know, with a black around it. Put a little toy car in front of that poster. Okay, and then set your camera up so you can see the Earth and the car. Then, with your torch, shine your torch only on the poster. Let's see if the light bounces from the poster and illuminates the car too. Just go ahead and do that. What will you find? That you can see that the car is red just from the light reflecting from the Earth. Now you might say, oh no, it's reflecting from the glossy finish on the poster. Like, oh, okay. Well, get yourself a matte poster. Go on.
Oh dear, but it gets better. At 5,000 kilometers, apparently, that only makes a very small little pointy shadow of the Earth. Forget that, it's just another crazy talk from Mr. Wally. But
And lastly, I'll
This is brilliant. Let's go.
show you a little diagram of the orbit of the Starman. It was 5,000 kilometers above the Earth, which gives it a circumference of around 71,000 kilometers, which means the maximum shadow, Earth shadow, would be the diameter of the Earth, which is about 12,000. But it's likely a lot less because it has to go directly through the center of the shadow to do that. If it just skimmed the edge, it would be a lot less, and that's exactly what it seemed to do. It was only in the shadow for a short period, so it seems like it just skimmed the edge of the shadow.
Oh,
So, Antonio,
bless. And because of that, you think it's true? Oh, it's sweet.
in summary, because it's true, light was behind the camera, as you can see by the shadow.
No, in your original video it wasn't, and that's why there was no shadow. In this one that you then went and made, pretending, oh no, this were the conditions in the original. No, it wasn't. You remade this video with the camera between the light source and the vehicle. You complete dishonest fool.
The black did not always reflect when the angle was low, as you can see by the red cap still
The angle was never supposed to be low, dim.
reflecting, yet the red paintwork was not reflecting. So clearly I didn't have the light at a tricky angle. I wasn't doing anything.
Yes, he was. We can see it. We can see that he's just moving the torch up and down and angling it. This is the problem with these globelings. They think that they fool themselves, and therefore the rest of the world is fooled too. Like, you can't tell I'm angling the light up and down. Like, yeah, we can, you fool.
Nothing weird or wonderful or surreptitious. It was just all as it was, and I've shown you even more clearly this time. So, sorry to destroy your dream and your fantasy.
Oh, bless. If only it wasn't for all that red we could see on the screen.
You're going to have to get Santa Claus into it now to fix it.
So that guy was in the chat. I think he might have gone away with his tail between his legs, but it might still be there. If so, it's going to be fun. I'm going to have some fun with him. Oh, true story. I mean, I couldn't make that up. If this was a farce, I've said this before, if this world that we're living in now was a farce written by some crazy genius, like written by Sartre with a mindset on comedy, it would be absolutely brilliant. Unfortunately, it's the real world. These guys really think that they're fooling people. Yeah, the sun's up there. Look, can you see? But it's not illuminating the top. Yeah, but it's up there. But can you see? It's like, no. Look, when you're doing that, it's not up there. Am I getting through at all? I've not timed him out. Where is he in the comments? I'm scrolling back. I'm watching. Nope. Oi. Where's Wally? The other cap? Don't understand that question. That's interesting. Now, back to AT2 Productions. Right. I said to him, go and find a line where it said, I don't want AT2 Productions to come in. Okay? He's gone back, because I timed him out, and he's pulled up the quote. But he's not really pulled up the quote. This is what he writes. From the War Dance Party at 1 hour, 15 minutes and 55 seconds. Your reply to the message from Reds where you stated you were only giving the link to him directly because you only wanted him to join. Am I lying? You're not lying. I have not refused. I've not said that that didn't happen. I've said that that's what I said. Where did I say I don't want AT2 Productions to come in? You're a moron. You've gone on, looked, and gone, well, he's not really said it, but I'll just repeat this, which he's already said that he said. I already said that, moron. So now I'm going to give you another time out. Maybe think about what you've been watching in this hangout. Okay, so take a time out. Now, where's Wally? Hey, where's Wally? Where are you? Are you trying to figure out how to angle a torch in a different way so people can't figure out that you're angling it? Is that what you're doing? Wait. First, I have to go and check that that is the Where's Wally channel and not a clone. Okay? So just give me a second. Because Globelinks, for whatever reason, no, that is his channel. Globelinks think it's okay for, like, okay, this is the mentality that globe believers have. I don't like these people saying that the Earth is not a globe. Okay, I'm going to spend hours and hours making YouTube accounts, cloning Flat Earthers YouTube accounts, and cloning Globelinks YouTube accounts, and I'm just going to go in to just cause some kind of confusion because that would make me feel better. Oh, wait a minute, I just read something good. Mark of Melbourne writes, a moron is a standard deviation lower than a dim-dim. Okay, I stand corrected, dude. Okay, so he's a moron. Anyway. So, that's it. Wait, let me look it up again. 4,714 meters wide. The moon, according to the data that Rhetoric had. Their baseline and the object in the distance, the diameter of the object in the distance versus the diameter in the distance of their baseline. 4.2, what was it? 4.29 times? Oh, it's interesting. 4,714 meters wide, the moon. Is that true? Because the math says so. Now, here's the thing for the Globelinks out there who are still watching, because there are Globelinks watching staying quiet. Okay, look. If there's some way that the moon has been established, some legitimate way that the moon has been established to be the supposed diameter of that great big moon out there in space, a legitimate way of establishing that that is its actual size and that is its actual distance, then if that same equation was churned through, was what did Red say? Grunt work. If somebody did the grunt work whilst there was an eclipse going on, you'd conclude that the sun was just directly behind the moon and the same size as the moon. Wouldn't you? Of course. Why would you not? You say, well, no, because here eclipse and here not eclipse. Like, wait, let's do it on the Earth's orbit, and let's do it, well, 6 months apart. Let's find eclipses of the moon 6 months apart, and let's do it then. Sorry, eclipses of the sun. And let's do it then and establish, well, oh, yeah, from here to here, this baseline much longer. Yeah. Sun, approximately the same distance away as the moon. Maybe 2 meters farther away. I don't know. Should we say 2 meters? Should we say 200 meters farther away from the same spherical trigonometry? But wait, did they use spherical trigonometry or did they use plane geometry? They used plane geometry. Oh yes, before I go, what's the time? Yes, I'm going to be going soon. I'm going to show Red's, just one last thing before I go. Remind me to show you this tomorrow, okay? We'll go over this. In fact, I'm going to make this a question, okay? What is this a cross section of? Okay, here. What is this a cross section of? Question for tomorrow. Okay. Red Astronomy Live. On a sphere, if they had a plumb line, they didn't. They had slightly diverging, okay? And when I say plumb line, to the azimuth, okay? So here would be a plumb line. There's the azimuth, okay? For both of them. Oh no, but with the spherical trigonometry, you have to include this sphere. What happens in the real world is this. They take plane trig, they then add the spherical trig, say, so this will be the curvature, and then they remove the spherical trig to confirm the plane trig, and say, see, the fact that we confirmed the plane trig, once having processed the curvature and having removed the curvature, confirms that the curvature is legitimate. That's what they do. But this was Red and the other guy's observation. Can you make a triangle out of that? No, you can't. What about the midpoint? Let's have the midpoint. Can you make a triangle out of that? No, you can't. Oh dear, that's a problem. Okay, and with that, I think I've timed it just right. I'm going to go into the chat, say goodbye to everyone. Poor Globlings. And where's Wally? It looks like he really did disappear. Orb's Realm. Allowing that comment. By the way, folks, if you write a comment and you don't see it, half the time it's just withheld. And just before I go, channels, subscribers have been first unsubbed from this channel continuously. This is happening continuously. But also, apart from being unsubbed, some of them are commenting in the chat. I don't see this, but other people in Germany especially can see. Google moderator team comes in, removes their comment and bans their channel from me, from being a subscriber and from making comments on my chat without letting me know and without putting that banned channel in the banned channel section of the community settings in the studio, in the back room to this channel. Okay, there's an area where you can see when I've banned people, there they are. Okay, when the Google moderator team ban people, they don't go in there. I can't find them to unban them. That's right. Okay, I've had 2 people contact me to say that this has happened. I've looked for them, they're not there. So this is happening. Why these dirty tricks? Well, because, well, reasons, that's why. Nicholas, thank you, man. I am well. Everybody else, thank you very much. Uppercut, level of server Adam thinks he's been blocked. Okay, so I will look, Uppercut. I will look for level Earth Observer. I can't imagine banning level Earth Observer. Okay, but I will look. If he's there, I will unban him. If he isn't there, I will just let people know in the next hangout that he's not in my band. In fact, I'll show that he's not there. If he isn't there, okay? Doc underscore Scranton. Who the F painted that shite behind you? Like, that's not a painting. That's a print of an illustration. It's not a painting, Dim Dim. Right, let me see. Messages. Okay. Educator Numpty, do you have any proof for that claim? Specify what you're talking about. Right, folks, that's it. I'm going. I'm just going to check to see if the guy specifies whatever it is that he's talking about. Do you have any proof of that claim? Maybe, like, spell out what claim you're asking for proof of? Because he's addressing it to me, by the way. Oh, and Doc Scranton, I'm going to allow that comment just so people see. You look like shit! Get it together, you meth! Oh, okay. I sense a lot of bitterness in you, Doc Scranton. Is your world being demolished? And, okay, so the guy hasn't written whatever it was that he was asking for clarification from, so I'm bailing. That's my alarm to go. Okay, thanks folks. I will see you all again soon. Rhetoric, he will now make another video saying, no, my triangles are right because 0.1212, if you divide that in half, you have 0.0606. Go on, dance for me, that monkey boy. Monkey boy. Oh, yeah, one last thing. Somebody wrote something about, oh, you're slowing down evolution. It's like, wait. Are you talking this evolution? Fish became monkey, monkey became man, man became woman. Morons. Bye all.